Welcome back to this stream, and we have a few people here. You might remember yesterday, or that was the day before yesterday, so it was on Sunday. We started work on porting TWANG, this game here. So essentially, it is a string of LEDs, and we will have a game with a joystick that we can play on a singular 1D dimension. This will be ported to the Icebreaker and run on the RISC-V soft core running on the Icebreaker with MicroPython. At least that was the approach we had on the last stream. I think I will still continue that path down, but as I described in the last stream, I was curious what different platforms people were interested in seeing for the Icebreaker with RISC-V, and the poll was very interesting. So I posted it yesterday on Twitter and on Mastodon. Both pretty much came out with the same results. The thing that people want to see most by a big margin is just C, C++, and Make. So just build it normally like an open source project with Make files and easy to use C code or C++. So that's the most requested version. The second and third, because they came basically in a tie, definitely on Twitter, but on Mastodon, Python was in the third spot. On Twitter, they were both tied with Rust. So Rust and Python pretty much equally deserved. And then further back, well, not that much further, but further back was Arduino as a framework. After talking to several people from different projects, including basically I came to the conclusion that depending, this progression is anyways feeding each other. So having C support will feed into supporting the Python, because Python in the backend for the embedded stuff will use C for the drivers. And we will have and also that would help with Arduino support. So if we get C supported, that will not be a problem to get Arduino to work. Rust will also benefit from that because we will probably generate the headers from SVD files. And then Tim Ansel, Mithro, he essentially said we have it already for FOMU. So essentially, we just need to take the FOMU code and get to work on the Icebreaker, which again is pretty much also done. So the main project here is something that I don't think is very well suited for just streaming, because it might be semi-boring. I don't know. But I think I want to do that mostly off stream, just take the examples that already exist for FOMU and make sure that they work on the Icebreaker. If they do work on the Icebreaker, I will then post repositories with examples onto the Icebreaker community page. And let me see here. And then, or not community page, in the GitHub organization of Icebreaker, there will be more example repositories. Currently, we have just for the HDL level stuff, we have Verilog, we have MyGen, we have NMyGen, and we have iStudio. And and now we want to also have SoCs, RISC-V SoCs available, which will be based on what is already available for FOMO. So I will take that code, make sure that it works, and port it over to the Icebreaker using the serial port as the communication interface. So that's the plan on that end. So the poll that came out of my pondering about what to use for TWANG definitely led to some good results, and I now know what is the priority and what I should just try out and port and get to work. So we will do that. For the streams, I think we will still continue on the porting on the Python stuff, because I feel that eventually, through the pipeline of the other platforms, we will also get to Python support on the Icebreaker, and this will be a very nice demo for the Icebreaker. And I also have a personal wish that I want to get better at writing Python code. So this is a good opportunity for me to use the time and learn development in Python. So that said, this is more of a demonstration here on my desk of where we are hopefully arriving eventually, but for now we are in Python on the desktop, and we are running this simulator that essentially, let's see, how was that, F10? No, it was Shift F10? I don't know, whatever. It's just run this. So we ended last stream with, wait, music. Again, I found another track that contains vocals. How fun is that? You should mark it, but let's just go to something else. Okay. There we go. Alrighty. So this is the emulator that it's basically just a Pygame, and we are drawing those rectangles, and in place of LEDs, we can move a character around. And while in between the streams, I did a bunch of refactoring to clean up the code base and make it easier to read. As you remember, it was quite a spaghetti thing that we had. So let's see, maybe not favorites, but structure. Does that show? Yeah. So currently in main, we just have the main function and then the player class. I moved everything else into its own objects and modules. The main thing I did, which took the most, so the simple thing, let's start with the simple thing, is just move the screensaver into its own class, put the global variables that define one of the effects into the class members variables, and then moved the tick function as one of the functions inside the class, and that's it. That was pretty easy. The hard part was me working on the LED string representation. So the code before was using for the string itself, it was just this class here. Let's see, why is this? There we go. Let's go just down. So we have the letString class, and it was just an array of tuples for RGB. And because I wanted to make the code a little bit cleaner, so that I could assign things to the LEDs themselves and modify them in place and do operations on them, I moved that into a class itself. So now we have an LED class, and this LED class, so we can actually unfold it here on the left, and we can see what I'm not sure this is the best way of actually looking at it. Okay, so the LED class itself just has the RGB values. This is the default setting that we have, and we can set that, and then we can also assign RGB directly to the class or access the member variables RGB. What is the most important thing is, for me, was moving the hue, saturation, and value converters as members, as functions of the class itself. In the original Twang, it is using the HSV conversion that is part of FastLED. And while I was porting this, I realized that the person that wrote FastLED, they really nerded out hard on the on the color wheel and color conversion part of things. So what I learned is, if you have HSV and this, you convert that space into RGB, there are two ways of doing that. You either have the hue as computated spectrum or computational spectrum versus rainbow. And rainbow, or the physical spectrum when you split light, is different than the computational spectrum. So there are two functions inside FastLED. One is just the computational spectrum version, so HSV spectrum, and the other one is HSV rainbow. And the most important part about rainbow versus spectrum is that you get more yellow in the rainbow version of it. So you have a more, as we perceive it as humans, more even distribution of colors in that spectrum than you would when you just use the computational spectrum. Yellow is pretty much disappears in like a very short sliver, for example. So, and green is overwhelming because it's brighter. This is also another thing that you see in the comments if you read FastLED. He says the most common algorithm for converting HSV to RGB is the one that is listed on Wikipedia. Duh, of course, because that's where people go and then copy that algorithm. And that algorithm, or the most commonly copied one, is copying the value, so the brightness of the color, as direct representation. So if green is full brightness or blue is full brightness, it is considered the same brightness as yellow being full brightness. And the interesting thing is, yellow as a color is being perceived as 95% of white, of like how bright we perceive it. So you would need to compensate for that if you wanted to have an even brightness between the different colors perceived, especially on LEDs, because LEDs have very high dynamic range. So that all said, I transferred and ported all that code over to Python. I did clean it up and simplify it a bit because I was not as concerned with performance as FastLED is. So the code hopefully should be a little bit easier to read than the one for FastLED, although the fast LED code is very well documented and works really nicely. So, and it is actually not that convoluted by optimization, but I didn't need to, or I didn't feel like I need to do the optimizations at the moment. Interesting will be when we start moving this code from the computer to the microcontroller using MicroPython or CircuitPython, where performance will start becoming an issue again. So what might happen actually that these functions will move from being Python implemented actually to being implemented in C. So we might come the full circle from porting the Arduino C++-ish or C code to Python and then transferring back to C. But then we probably can copy stuff one-to-one from the FastLED library. So that will be very interesting. Okay, so I ported this, put it in its own class. Now what you can do is you have an LED, for example here in the screensaver, and you can take the LED and scale it in place by the 250 divider, the thing that I was explaining on Sunday. And you can also assign an HSV value to an LED directly, and then it will automatically convert to RGB and set it in place. The interest, so I was planning to have also the capability of retrieving the HSV values from the RGB representation. The problem is I didn't write the inverse of the conversion yet. I might do that eventually, but for now, I think this is good enough, and we can continue moving. Especially on the stream, I don't want to do this nitty-gritty porting of I don't know, semi-boring stuff like the color wheel stuff. The thing that I definitely learned doing the porting is how to handle fixed point math a little bit better, because all of this is meant for a microcontroller that has only 8-bit registers and stuff. So we are not doing floating point math on the original platform. So all the functions here are meant to be fixed point. And I think I will just leave it that way and continue doing it this way. So what I had to learn is there is actually a difference. So there is a difference between Python 2 and Python 3, where divide, so the single slash in Python 2 seems to not convert to floating point, but in Python 3 it does. So I was making tests. I was running just Python on my command line and using the REPL there to do some experiments with the math to understand how it behaves. And I then started running into issues in the code that I was writing, and it didn't make any sense. And then I realized that my command line Python was the version 2 instead of version 3. So yeah, I was not, the results I was getting in the experiments was wrong. So here I have to prevent Python from converting the values from fixed point to floating point. I have to use the // the double divide that will then force Python, the interpreter, to not convert and keep it fixed point and put it into the variables. So that's what I learned here. And next, I thought I removed this. Yeah. I still have to filter more stuff out. Let me find which one that was, just so that I know for later. there it is. Oh, it's Wolf Club. Yeah, I think the whole album I have to remove. Okay. Okay. So, last time, so so let's get to some coding and adding some of the features of the original game to the code base. The thing that I ran into right after, oh my goodness, I really thought I have to really do a better job here. Okay. So let's focus. Let's get back to it. Okay. So I have implemented the player. So we can already move the player. Think like this. Shift F10. There we go. There we go. And I can move it. The problem is, as you see, if I just do this, it gets stuck. So what is happening is that I was essentially removing the direction. Let's look at the code here. So if the key is down, I move left or right and I set the direction. And then if I do key up, it only sets it to 0. So if I press both buttons, so I press to the right and then to the left and have both pressed and then release to the right, it will also stop moving to the left, even though I still keep pressing a button to the left. So what I think I have to do here is, if key left and direction is to the left, then I should set it to 0. If it is, yeah, let's try that. But I have the feeling I might, yeah, no, I think that should work. Player speed is -1. Oh, what is going on? Control Z, there we go. And then LF. Is 1, then player speed. Yeah, I on purpose have not fixed this during off stream because I wanted to do that here so that we continue on the same streak of what we were doing. Oh, we are crashing. What's the problem? Invalid syntax. Oh, it should be equal, right. Oh, yeah, so as I said on last stream, I wanted to a better theme, and definitely the dark theme is better. And I changed the font to use ligatures, so then we have, and it looks nice and aesthetic. Okay, so let's see. Yeah, it seems to be working fine. Yeah, there we go. That's nice. I want to kibitz. Hi, Kernel. Hi, Bob. Welcome to the stream. So what are you saying? Want to kibitz up left speed +1, up right speed -1? Up left. Oh, so to decrease it? Speed should be 0 when both buttons are pressed? So if I do press button down, I add. If I pull it up, I remove. Huh, yeah, we can try that. We can try that. Let's comment this out. Let's make a copy of this code. And I thought I switched off notifications. I still am getting notifications on this desktop. Oh well. I have to figure out what notification system is running on this laptop. So let me just, yeah, I have to I thought I copied this. So this is... Okay, so let's do this. So you say we should just minus equal 1 plus equal 1. So this will cancel itself out. And then if we have we assume we will never lose. So left should be plus equal 1. And then right would be 1. Oh, come on. Yeah, I really have to move this whole thing into Sublime Text, especially on this computer. Oh, because we are running it in the background, I guess. There we go. All right, so that stops, releases. Huh, that is not bad. to the right, to the left, to the right, to the left. That's not bad. I like that. Thank you, Bob. That's a good idea. Yeah, we will leave that this way. Can always change our depending on the gameplay. Okay. What was it complaining here about? Come on. Indentation is not multiple of 4. Oh, there we go. Yep. Okay, so exit. If my keyboard auto-repeats, yeah, it would auto-repeat, but I don't think this happens here no, I don't think this happens in Pygame. I think Pygame is actually reacting to the events and not to the actual keyboard events and not actually reading the characters. I think this is on a different layer. Hold the key down for a bit, if it will reverse or something. I should actually indicate what the speed is. Maybe we will see a flicker. Yeah, no. Doesn't seem like it is a problem. Let's still do here. Let's add a second one. Just S, so player speed. Then and player speed and just player speed. Let's see how that goes. And then 1. Yeah, it's stable. I think my auto repeat would be bigger than this. Yeah, I think it's fine. It's staying 1 and it is not flickering back to 0. Yeah, I think it's fine. I should do something so that it doesn't flicker like that with the ticks. Should probably have just Pygame ticks and then do it in decimal. Like this. Yeah, that's better. It's just showing seconds. There we go. It's much more pleasant, isn't it? Okay. So let's commit this. First, player movement. There we go. We want to not have... Yeah, let's commit the whole thing, I guess. And commit. Can I hear push from here too? VCS, git, push. Is there a push here? Yes, push. Let's see if that works. Origin master. Let's see if that works. Okay. Bob, you should get a notification from GitHub. All right, so that works. Okay, so we have the player. So now let's look at the original code again. Twang. Oh yeah, I think I have that in Sublime, right? Oh, one more thing I can commit here. So one thing we can do is the screensaver is pretty much complete now, and in the README it was not marked as such. So the screensavers were done. Yeah, I wanted to show you also one more thing regarding the screensavers. So because I used the HSV converters so I was, in the last stream also, I was saying that the colors were not, probably not correct in this emulator. And that was true because I was using the Pygame HSV conversion, which is probably a different balance and probably computational spectrum instead of rainbow. So it definitely looks better color-wise. What also happened is it was very dim suddenly. I thought I was very confused why it is so dim. So I think what is happening is the LEDs do not have gamma correction. You have to do gamma correction yourself. So the parameters that are set inside Twang are based on not gamma corrected values. So they are quite dim in the lower end because it is brighter. It's like the curve is linear there. So, and this is why you perceive going from very dark to bright very quickly and then tapering off. So the values are quite low to get into that kink of our visual perception. So to emulate that correctly here, I actually applied an inverse gamma correction to basically get that effect back also in the emulator so that the colors look more realistic to what they would look like on the LEDs. So that's a side note here. Cancel, commit. Yeah, so we implemented screensaver, we can commit that. And let's push it. All right, that's pushed. All right, so next. Yeah, we wanted to go back to the code here. Draw player. Let's see what it does. Take enemies, take startup. What could we do? Could theoretically implement levels, or we could implement the enemy. Implement enemy count. Spawn enemy. So this is a factory here. So you spawn an enemy and it basically uses a factory to generate those. Okay, so let's go to the main code here and see. So you have player position modifier, can move around. Joystick will wobble. Attacking. Could create the attack animation. Attacking and attack melees, attack duration. Yeah, we could implement attacks on the player. How is that implemented? Because I know some levels have shorter attack distance. Player position. Conveyor. Drainage spawn pool. Oh, that was in the TWANG 32, the video that we were watching. It was actually different TWANG implementation. Let's look at that a little bit. Let's look for TWANG 32. Okay, so that's the code. Let's look in here. Player position. Attacking. If not attacking, is this. And if attacking, yeah. But also I wanted to look at the levels here, where it has a shorter swarm, player position. In that video, he was describing that in some levels, the attack distance is smaller than in others. I don't see that. Yeah, weird. Because I would imagine this is like a player variable, where how far the attack distance is. But that's fine. Let's go into... Let's try to figure out the way attack is implemented. So attacking, so basically you have not attacking and joystick wobble, user settings, attack threshold. So this is essentially if the joystick is being wobbled. In our case, we will just set the player to attack mode. We might want to, let's see, we have it as move, but we don't have a tick. Okay, and attacking, let's see where attacking is also being used. Come on. Should pop up, shouldn't it? So let's see where that is being used. Tick enemies attacking. Okay. Draw attack. I see. So this is a special function that is also in the top level for some reason. I think player draw should be doing this. Player draw. So I should be setting it into... Oh, hey, Captain Morgan. Welcome to the stream. Yeah, we are working on porting TWANG, the 1D dungeon game, to Python from Arduino. So that's the project we are working on. Hopefully it will end up on Gauntlet? Okay, you made your own version. Okay, let me look at that. Is that on GitHub? Yeah, let's search for it. Yeah, I should just copy your link, huh? There we go. Just realize how much I have muscle memory for this keyboard on my Mac, because I use the keyboard IO keyboard on my Mac, and some of the buttons are like the key assignments are a little bit different, and muscle memory is horrible. So yeah. Oh, cool. Oh, you implemented in proper C. That's nice. Yeah, that's neat. That's probably the game itself, huh? Player, yeah, instructs, yeah. That's awesome. Yeah, we should run it on a RISC-V when we have the hardware. We should run your code on the Icebreaker RISC-V on the LED string. That looks pretty nice and small. That's nice. That's cool. Thank you for sharing. Yeah, we should try that on the Icebreaker as one of the C targets. As you might have seen on Twitter, I was asking what platforms people want to see, and C was hands down the winner, or C++ and Make. So so yeah, we should definitely run it on the C target to try it out, and maybe provide it as an example for that platform. What do you say? That would be fun. You had the first vote. Oh, wow. Thank you. Congratulations. That's awesome. Okay, so let me try to read this code, what it is doing here. So it is using time, and it's using this global attack melees. So we should basically have a method that initiates the attack and then renders the attack. Player position plus attack width. Attack width. Is attack width? this should be a init variable of the player that can also be changed. Let's see. Attack width, default attack width. Yeah, we should check what that is. It's probably in settings. Default attack width is 70. Oh, because we still are rendering on the virtual platform there. Right. It's 1,000. Yeah, I should really take a look into this, how I play on this virtual 1000 LED playing field and then shrink it down to the real one. Should we do that now? This is boring. I don't want to do that at the moment. So yeah, 500 milliseconds. So it is half a second attack. And 70, and that would be then 7, essentially. Like, because it's 144 LEDs long, and the playing field is 1,000. So yeah, roughly half. Well, it's more than half. So it's like 8 or 9. It's like I'm terrible at math, but that's the feeling I'm getting there. So that would be that. Then attack width. This is taking. This will be interesting how we do collision detection with the enemies. Enemy position. Attack width through 2. So let's see how that is still rendered, the attack. Take with draw attack, there we go. Oh, so this is being drawn. Get LED. Player position. Get LED. Constrain. Oh, I see. It is using this get LED function to scale it down. The world is 1000 pixels wide. This converts world units into the LED number. Should we make that part of the... Yeah, I will eventually add that to the LED string methods to get an LED in the different coordinates, in the different coordinate system. Yeah, this is an Arduino function, the map, where you can map one range of numbers onto another range of numbers. I think I did do that math here somewhere, doing the conversion. Yeah, I think I did here in the screensaver. There's a similar thing happening. Yeah, this here. This is also mapping from one range to another. If I remember correctly. Yeah. Yeah, it might be useful to have just a function for that. Okay, so what do we want to do? We want to... Let's move the player into its own method, into its own... not now. So let's just do... attack self, yeah. Attack and should we set it as internal? Attack width should be some default. Let's make it an 8 for now, and then attacking, was that the, yeah, attacking, false. So these are the defaults. And then attack melees, and we should have that attack melees, attack time, something along those lines, right? Attack duration. Why is it mapping that too? Oh, that's the length of the attack. Oh, it's the color? Right, it fades in and fades out. Right. So it is using the CRGB to do a blue attack, and it is going from mapping the time oh god, I have to see what the definition of that stupid map function is on Arduino. I don't remember what the so what is it? It's value from low, from high, to low, to high. Value, the number to map, the lower bound of the value's current range. So low, high, low, high. Okay. So it is doing the value, which is melees minus attack melees, from 0 to attack duration, from 100 to 5. So it is reverse mapping the time to a value between 100 and 5 and 5. I'm curious. In Python, we could just do that with a range converted to a list, right? That's horrible, though. Like allocating a bunch of memory just for this. No, that's horrible. You're not doing that. Unless Python is more intelligent than that and it does something tricky there. I would have to look this up, because the nicest thing would be to essentially create a range with values that are in a different range, that are evenly distributed. That would be a Python way, I guess, to do that. Okay, so where are we? So we have the value of the brightness, then we have the LED, so for EI, which is the position, the mapping of the position of the world to minus attack width half, to player position plus attack half, I, and then set it to blue. If n is over 90, then set it to maximum, It's creating like an additional ramp. Oh, it is. Holy moly, what is it doing here? Player position. So the central one is either white over 90 or green below 90. And then it's setting it to white. Oh, that are the ends. So basically it sets the center and the outer two of the attack to white or black, depending on the end value. So the time. So it is just doing the white in that section. Damn, okay, cool. All right. How do we do this? How do we do this? How do we do this? So first of all, we have to initiate the attack. And to do that, we have to set it to attacking, set attack millis, and have an attack duration. We need attack millis, and then attack duration should be also a variable that is settable. And this was 500 millis. There we go. And then attack, and then time. So let's pass time to it. Self dot attack millis. Yeah, we should for the move. Yeah, we will need to do something around a tick, I think. So not just draw, but actually have a tick for the player. Yeah, I am already starting to rebuild it in a different structure than the original code. So that's, I knew this will happen. Attack millis is time. And then attacking is equals true. They also blanked it out that, oh, and I can't move when I'm attacking. So if self dot attacking, then return. So we are not doing anything. We are not moving if we are attacking. And let's draw attack. Let's make that a function. Later we can combine it into something. You can refactor it again. Draw attack. Syncing the player take to the drawing. Yeah, I have to think about the overall structure a little bit more. Where I want the time to. I am currently passing time, the current time, to the functions that need that information. because otherwise I don't want to make it dependent on what framework I'm using. So I only want to do this. Currently, I'm only selectively doing it. I might have an object that I'm initializing all the objects with, and then just have each object just do a tick and then draw in layers. So that might clean it up. So the current time would be set in a class that everyone owns, everyone has access to know the current time when it needs to. And then run tick, then it does all the updates of the internal variables. And then it does draw so that I can layer things on top of each other. The important thing is then, I still have to figure out how I do the factories for enemies. So everything that exists more than once in the game, I want those objects to be pre-allocated, just like the C implementation, so that we don't do a lot of memory shuffling, of allocating and deallocating memory, because that's usually very expensive, like a waste of resources to do that when we are running it, and we will be very computationally constrained when we do that. Well, maybe you can maybe you can now go back and clean up some code. Maybe it will motivate you to work on your C implementation if we get it running on the icebreaker. That would be fun, actually. Then we have a C implementation and a Python implementation, and then we can see how much more. Yay, more project. Well, you started that project. You just didn't, it's not finished yet. Yeah, I love starting new projects too. It's a problem. I'm not saying I'm innocent here at all. On the ESP32. Why ESP32 and not an icebreaker? Okay. So let's do the draw attack part. Attack duration. So we still have to do the draw attack. We need the time. We need to tick. Damn it. Okay. We need to tick. Right. We shouldn't do move. We should do tick. This should be tick. And draw should be doing also the attack drawing. Yep. That's the correct thing to do. So tick. We should set the speed as its own thing. Yeah, and it shouldn't be in here. It should be a variable dot speed. Speed should be 0, so we can set the speed directly, and then tick. Yeah, that's much better. So much better. So if it is attacking, then we can do the attacking animation here, or we can ignore that, but yeah. self-speed. Yeah, Captain Morgan, maybe you should get an icebreaker. Get into the FPGA game, just like we do. Yeah, no, I understand the SP32s are pretty nice. It's like having Wi-Fi, wireless, and a lot of memory. It's pretty nice. So for the icebreaker, what I was thinking regarding memory issues, so the Python implementation might require more memory than we currently have, but we are running it only on the LED string. So if, and I'm not saying we do, but if we run out of RAM, we have two options: either solder on an additional SPI RAM on top of the flash chip. That's what this pad next to it is for, to have an additional chip select for memory. Or we can attach HyperRAM. And I just got these new prototypes of HyperRAM where can you see this? Yeah, 4 HyperRAM chips, plenty of memory, no problemo. So yeah, we should be able to run Python pretty nicely on this thing. But then we have the joystick and the LED string connected to the head PMOD, because we need, for the LED string, we need 2 pins, and for I have not, so Bob is asking if I tested it. No, I have not tested it yet. I know that, but I know that Sylvain tested it, so TNT has tested it. I have not. Yeah, I should test that eventually. But also the whole FOOP, or like MicroPython on LaTeX RISC-V. This will be interesting because we need more different memory types, and having HyperRAM as memory target, or SPI RAM, that would be really nice to know, because the SPI RAM is just QSPI, so it is not as fast as the 8-bit HyperRAM. So so this will be interesting. Yeah, okay, so where was I? Draw speed. Speed is 0, so we can set speed, then we can do tick, and then attack would set millis to time, and then yeah, this is the inconsistency. So usually this is, I am very curious how the Python community guidelines, how they see it. In C++, you would have setters and getters for everything. So if we have consistently for all the variable setters and getters, then additional processing would happen in one of those. But here, attack is the only one currently that needs to also set millis, while it is also setting attacking, and everything else is just you can set it directly in the class variables. So I don't know what the normal coding style approach is that the Python community came up with. I would have to look it up. Okay, millis, attack duration, then we have, if it is attacking, return times direction, so it is the amount, and then we have amount, and then we are bounding it. Okay. Okay. If attacking, then do, and we can make it a private function, And the draw should do it, right? Ah, yeah, we are only modifying our status variables. So let's look. It is essentially just checking that's up here. I think it's up here. Oh God, where is it? Oh, spaghetti, spaghetti, spaghetti. Attacking, and plus attack melees plus attack duration. Then it will reset. Attack melees plus attack duration. Oh yeah. Melees plus self attack duration is smaller than time. Then self dot attacking equals 0. False. There we go. Mr. AZ, thank you for following. Welcome. The Pythonic way it to assign directly to member variables. If you need side effects to provide a computed value, you can use a property, which is a method triplet, getter, setter, deleter, that acts like a member variable. Huh. Okay. Interesting. I will have to look up what... let's do that. Python properties. I will have to read up on this. Oh, it's with a decorator. Interesting. Is that right, that these are... Okay, I will have to read up on this. Okay, cool. Thank you, Bob. I will keep learning new things. Okay, so if attack melees plus attack duration is smaller time, so current time, then attacking is false, so we stop attacking. And in draw, we should let's look at this. How is it done? Let's go back to the draw attacking. This is the special effect. This is audio effects, so we don't care for that for the moment. Where are you? Draw attack. There we go. So, how do I do this? We should invert it. I should have a map function, just like this one. It will make porting of this easier because yeah, it's using map all over the damn place. Yeah, so how is... I will just, instead of breaking my brain, I will just look in Arduino. I know, I could probably just... Yeah, there we go. Let's just copy this. Let's create just a def. Oh. Keep pressing the wrong buttons. There we go. Map. So this is X. I'm sure there is something in Python, in math library, that does that too. But I will not do that now. Okay, so let's remove this. There we go. The divider should be // yes. There we go. Okay, so let's see. If not attacking, return. So let's, and we are drawing ourselves if n is 0 map. Yeah, we should just do not self.attacking. Why is it not? Ach, not. Should I type self-attacking? Then let's do this. L. Let's do self. Draw attack. And yeah, that should do it. Then we can make a private function for this. Private method, sorry. Draw attack. And now we can do the following. First, let's map it to n. So n. Oh, and this is where we need the time. So draw now needs to get the time. That's why having it global would be useful. Time, and then draw attack also needs time. N is equals map. Oh, I shouldn't overwrite this because map is yes. Yeah, it's a Python 3 thing. I think Python 2 did same thing for both, and or if there was an option that you had to enable or whatnot. But yeah, I confused myself by running Python 2 for stupid reasons for testing. Range map. Let's call it range map. Let's do range map, and then the value will be millis, attack millis. So time minus self dot attack millis, and then it goes from 0 to self.attack duration, and then from 0 to or the other way around. No, 100 to 5. 5. Okay, so that's one. Now, then we need the LED mapping, but let's not do that. Player position is currently in the direct space, so we don't need to get LED. Attack width divided by 2. So 4 En, what is the range? From 2, yeah, I can, and then step. From player position minus attack self dot position minus dot self dot attack width divided by 2 plus 1. Why plus? Oh, plus 1 because we are cutting off the very tips because we want them to be the flashy ones. Okay. And to self dot position plus self dot attack width divided by 2 minus 1. Yeah, so that's the range. And then LEDs self dot LED string I equals, no, it is CRGB, so just let's do the RGB thing. This is the new function that I added. Yeah, I should probably remove the vector thing. I should make it so that it automatically detects what I'm giving it, but so R, G, and then N is B. And then let's do the tips. If N is larger than 90, then N should be 255, and self dot LED string I player position, no, not I, so dot self dot player position. Come on. What is going on here? Oh, position, just position. Yep. And then dot RGB 255, 255, 255. And then else N equals 0, I think. And then let's do it green. Self dot LED string And then the last thing is to set the end bubbles to something. So self.letString self.position minus attack width divided by 2. Oh, let's not forget this. Equals n comma n comma 255. So it basically will fade from bright blue to just blue. No, and we are doing the wrong thing here. GB. There we go. And then self.letString. Yeah, I could just copy this line. Ah, come on. Is that doing the same thing, but just minus? Yeah. Plus, I mean. Okay. Draw attack. The time. Okay. Let's see. So now, so we should do that for the up and down buttons. So first of all, we should do tick here. Oh, draw is correct. Draw is still correct. But we should add. No. This is. What are you doing? So, string clear, yeah, and then player. First player tick. Tick. Time. Where do we have this? Do we have this somewhere? PyTime get ticks. Huh. Am I not doing it anywhere yet besides the timing here? Ah, no, there it is. Pygame get ticks. So we should probably just take it at the beginning of the frame and pass it on. Clear screen. Yeah. Time equals pygame dot time dot get ticks. And then we can just use this here. And clear tick time, draw, and then time. And for the direction, player speed, we don't need to do this. We can just adjust it here. Yeah, we have player speed there, but we can do this player dot speed equals player speed. We could just set it over there, I know. We could just set it above, like in here. But yeah, tick, draw. Okay, let's check if that makes sense. Tick, time. Then we should also call attacked. We will do that in a second. So let's try this. If it still behaves as it did before. Okay, so where are we crashing? Line 7. Oh, there's a colon missing, of course. If it is not semicolons or or brackets, it is semicolons. PyDev process is connecting Pygame. Okay, so that seems to be working. Oh yeah, no, it's fine, it's fine. Yeah, I'm curious how that will feel when you're actually playing it. Okay, so that at least works. So now let's add another, just a key down for the other ones. Elif key equals Pygame k up or event key equals Pygame dot k down. This would be the attack. And player dot attack, and then time. Oh yeah, time. So I should probably do it earlier. Yeah. So we should move this. Let's do it here. There we go. And then we can actually remove this and set player speed over here while we're already at it. Player, yeah, we cannot increase it here. Yeah, I have to do it as a variable for now. Yeah, I should probably have like increment and decrement functions here. All right. Let's see. Wow, that does work. Nice. Now we have... I'm pretty sure this will look better on... Yeah, it stops, as it should, and it continues. Yeah, very nice. Yeah, so we added attacking. That's neat. Okay. So... So it is creating the effect. Now we should, yeah, I think we should commit this. Yeah, we are pretty close to the end of the stream anyways. We have another 20 minutes in theory, but I'm not sure I want to dig into the next thing. We will see. Maybe we can do something small. Yeah, so let's commit this. Let's see, what did we do? Oh. Let's go in README and then player attack shield. We can mark this also as implemented. Oh, it is not interacting with enemies, but it's a start. Yeah, I think changing levels, this is something we will add later, but for now this should be good enough. So that's that. Let's see. We added the range map. That's useful. Yeah, this will probably go into a module called like helper functions or something. Init, and that's we added attack with attack duration, so we can set it at startup if we want to. We added the attacking stuff, yeah, time, and then the private function for draw attack, private method, I mean. Tick, 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 good, good, good. What? Oh, this is just what is cut out. Okay, cool. There we go. And push. Okay, cool. Oh, hi Ed. Thank you for becoming a Patreon yesterday. I appreciate that. And yes, I am still going on to the Python implementation because I think that is more fun. The other stuff will definitely happen though. We will, but I will not do it on stream, I think, because that will, it's, yeah, I have to take the stuff that Tim already made and what you are working on, what you are digging up, and try it out on the icebreaker and publish some examples for it. And yeah, help is always appreciated for this kind of stuff. So if you want to help out, you already did by looking it up and checking if the things work. That was very helpful to see you talk to Sean yesterday on Discord. So that was very good. Thank you so much. Yeah, okay, so let's see. We could. We could try, we could just move the player into its own yeah, let's move the class for the player out and move this into utilities. Let's create a few more. Yeah, let's keep the code clean. Okay. File, a new Python file, and call it player. And then add it, yes, sure. And then we can move this. So that's one. What are you missing? Range map, yes, of course, because we are missing this. Oh, what is the semicolon doing there? Python, you are too permissive. But yeah, no, the semicolons are actually a supported way of, I think you can then put things in one line, even though it is not the Python standard. Well, that's what I do. So I'm glad you are at least reading it. You can test my stuff that I will be testing, like test examples or something. That would be already helpful. So don't worry about it. Yeah, I have to just try it out myself and see what the status is of the code base, and complain to Sean when something doesn't work. So he hopefully can fix it. Yeah. New Python file. Just utils. Let's call it utils. Just that. Yeah, I should also add a license to this, right? Yeah. What was this, the original actually licensed as? Curious now. I should just look it up here. Yeah, it doesn't have any license on it. God damn. Based on critters. Critters twang, yeah, and then license. MIT license. But they didn't put MIT license headers on any of the files. Great. Well done. Ah, God, it's, yeah, this, I remember doing that a lot in the past. Just go, I want to try using this project. It's like, where are the license headers? Okay, that's obviously my first pull request, to add license headers to all the files. And then people are complaining, oh, you can't do that because the developers didn't do it. It's like, yeah, but why didn't you add the headers in the first place? Who knows what this code is licensed as if you don't have the license headers? Anyway, sorry, it's just frustrating. And I am adding to the problem now by not having license headers myself. So, shame on me. I will fix it, I promise. All right, so this is... let's call it that. Okay, and we can delete this. And then we can go in player and then import utils. And then range map is okay. So let's see. That works. No, it explodes. What did I do? Oh, yeah, I should import the player, right? Import player, and then player. Okie dokie. Explosions. Yeah, we have attack. Perfect. Very good. And it is... yeah, very nice. Okay, cool. Yeah, let's commit all this. All green. Range map into their own modules. And push. All right. Okie dokes. So that's good. Yeah, I wanted to show you really quick also how the screensaver looks like when we what's doing here? Do this. Let's comment it out, and then because I don't think I showed you how it looks after my changes with the HSV conversion. Yeah, so this is how it looks, and you definitely see the rotation of the colors is different than it was before. It is trying to keep the brightness even throughout the color rotation. But with blue, it is really hard on the monitor anyways, because blue is always dimmer. I think on LEDs it will look better. This one was faint before too, but it is similar. Okay, keep going, keep going. Yeah. Next, please. Yeah, balls. They look very similar as they used to. I think the biggest difference is the rotation of the HSV, the like rainbow color change. I think that's the most significant difference that you see in the screensaver. Yeah, this looks the same. It's just, I think it is more intense than it was. It's crisper. I think the ramp is crisper because I cranked up the gamma. So I inverse the gamma so that it behaves more like an LED strip that doesn't have gamma correction. Yeah, they are more than 1 pixel. I will show you in a second. Yeah, and this is the last one, and it's just a dot. Okay, yeah, the screensaver is for, yeah, this is for the balls. Each ball is actually 5 pixels wide. Oh, that's why they were adding them. I just realized something. So there was addition happening for the LEDs. So now they're just overwriting each other. They were adding to each other before. I should do that. Oh, God. How do I do this? Right. HSV rainbow. Yeah, because I just want to take the value and add it. I should probably make another method that is not just assigning the values in place, but it is like HSV rainbow add, because this is actually an HSV rainbow, which is an in-place conversion. But in this case, it's not an operation. In Lisp, you would prefix all the in-place modifications with n. So in this case, if we did it functional, then this should just take the value of the RGB LED and then return the value instead of setting it in place. But yeah, okay, whatever. So we should create HSV rainbow add and do that here. So that's a good fix. Let's do LED string and then LED, and we need to create additional HSV spectrum. This is the same thing. Def. Oh, it is assigning here too. Damn. How do I do this? Oh, I should be doing it more functional. Functional programming, come back to me. How do I do this? The conversion should be a private function. Static method. I have no idea what static method is. Yeah, I'm learning Python. Yeah, I have to read. Yeah, this is a decorator. Okay. Yeah, I have to read this. I don't think I should do that on stream. Yes. Yeah, I will add this off stream, I think, and understand better how I want to structure it. So what I would do at the moment is essentially extract all the functionality from here that is just functional, which takes a value in and outputs a value as an output. And then instead of assigning it to RGB at the end, I would do that only in an N version of this, which is in place. But this should be, yeah, as you say, that should be, yeah, it will work. So this should be basically a class method, aka it is available always. Right. So I don't need to refer it to with self, I can refer to it with LED. This does make sense. Yeah, but I have to look at some examples how that is done correctly, where you have where you do that. What is the Python way of doing it? And I want to see how it is the correct implementation of it. So essentially not assign the values, have an N version of it, which is in place change, and then have one with addition, which is like you can say that you want this HSV to be added to the current value. So I will do that and commit that later. But yeah, we are pretty much at the end now. This is the 2 hours of streaming for today. So I will just save this. Yeah, we have the screensavers. Let me go back and return it to the original state. There we go. All right. So yeah, thank you very much for joining today. This hopefully it was somewhat interesting for you too. I will keep working on the Python port, and I will try to make additional streams and do some small sections of it on stream. Some of it I will do off stream and then give you an update when I come back live. I will also give you an update about the RISC-V icebreaker stuff, which I want to essentially take and port. And the one thing that will also happen because of me taking Tim's and Sean's FOMO stuff, there is a workshop, so we will get another workshop for the icebreaker, which will be mostly focused on SOCs and RISC-V, and how you can program them, debug them, and also add your own hardware. So that will be very interesting. I'm really curious how the debug bridge works over UART, as well as the Wishbone tool. Yeah, if you see, it's like I was using a fountain pen and my fingers are all black. Separate story. I just realized that my fingers are black, and it's I like using fountain pens, so my fingers are dirty sometimes. Yeah, so I will keep working on this, chipping away at this. Also keep working on the Glasgow campaign, which is still being prepared. I chip away on that slowly but surely, as well as a bajillion other to-dos that are happening every day. But thanks to you all that are joining into these streams, that helps a lot to motivate me to keep doing this. I hope this is somewhat interesting for you and you are learning something too and enjoy hanging out with me. Yeah, as last time, I would like to give a big shout out to the Patreons that are supporting these streams and making them possible. And now I finally have a proper list of people, not like last time. So thank you, Ed, for supporting it. He just joined 2 days ago. And then Jerzy Hacker, and then Journey Parky Rodriguez, as well as Sid Price. Thank you so much. And regarding Sid Price, check out his CTX link. It's a crowd supply campaign for a wireless Blackmagic probe, which is a very nice tool. So you should check it out. I think it is available for pre-order there. Yeah, so that's it. Thank you very much. And thank you for watching. I will try to actually do a raid this time, because I wrote myself a note to do a raid. And yeah, let's see who is online. So we will raid Endesga, who is New Zealand. So he is a game developer. He's writing a really awesome computer game, retro-inspired, pixelated graphics, and he is making streams pretty much every day, like hours, 6 hours a day, showing his process of designing a game and writing a game from scratch. He's almost done with the game. But the streams are very enjoyable, because you see the progress of him building stuff using Game Maker Studio 2. And yeah, I can really recommend that channel. So say hello from me to him, and see you over there.